Okay, we're continuing our introduction to the Arduino Student Kit meant for young people. And before we get into the next lesson where we actually build electronic circuits, this is a very good point to start talking about safety. This is actually from our Getting Started Lesson 0. At the end of it, there's a section on electrical safety. And I hope you kind of look through that yourself. I think you know you're not supposed to stick your finger in here. You know, if you have a receptacle, it's actually pretty hard to get your finger in there. But people have been known to stick paper clips and other things. Actually, the newer outlet receptacles have the little shutter inside, so it actually makes it hard to poke something in there because you have to push something in both sides at once to make that open up. So they've newer ones, at least in the United States, are called tamper resistant to make it hard for you to put a piece of metal in there, like a child to put a paper clip or something. So let's look in our student logbook. On the right inside the front cover is this safety quiz. So let's go over some of these. So the first question is, what of the following is a potential hazard from dealing with electricity? Okay, is it you get a shock? Is it that you could get burned? Is it you could get nerve damage? Could you get electrical heartbeat? Or all the above? I think you can see that this answer is really all the above. It's actually really one other thing. The reason you get electrical damage to your heart is electricity can damage the nerves. It can also stimulate your muscles to clamp up. So people have been known, if you touch something with a high voltage, it kind of activates your muscles to cramp up, and what happens is your hand can clamp on it and you can't let go. So electricity affects your nerves and your muscles, and your heart is both nerves and muscles. That's why it's extremely important that you don't want to get electricity like across your heart. So one of the first things you want to get in the habit of doing when you work with electricity is you want to make sure you don't try to avoid using both hands at once. Because if you get a shock across from one hand to the other, it goes through your arm and across your chest, right through your heart. So that's why you really want to avoid touching something with both hands at once. Kind of similar with your legs. If you're standing in a puddle and grab something that's electrical, that's a bad thing because the electricity will go down through your body and across your vital organs, particularly your heart. So you want to avoid, if you're going to get shocked, you want to get just maybe with the back of your hand or just one hand. You don't want to go across your hands or from your hand to your foot where it goes across your body. That's where it becomes really dangerous because it can damage the muscles, particularly the muscle of your heart. Another little important thing is when you're using your multimeter, notice it has little electrical probes. Now some people might tend to want to hold this like this with their fingers on those so they can touch things, very accurately. Well, that's the worst thing you can do because what you're doing there is you got one hand and the other hand touching something electric when you touch this onto something, which is going to cause electricity to go through your body. So notice how these little probes are designed. There's this little ring that sticks out. That's to keep your fingers behind those. So when you touch something, keep your fingers behind those rings so you don't touch the probe or any possible electrical metal thing that you might be touching. So the important thing is if you avoid touching metal stuff, and particularly avoid touching it with both hands, you're going to be a little safer. Okay, question 2. when you're working with circuits, is it okay to do what? Is it okay to work on a metal surface? Like a kitchen counter. Sometimes people have a metal counter. Is it okay to work on that? Is it okay to have an open beverage nearby? Like maybe I'm drinking my coffee at the same time. Is that a good idea? Is it okay to work with power supplied to the circuit? Is it okay to wear metal jewelry? Well, this again is probably one of those ones where it's none of the above. You don't really want to be working on a metal surface because that can conduct and you could lean on it and then touch something and get electricity through your body. You don't want to have something liquid nearby because anything water does conduct electricity, and it's bad for you. You could get shocked because of that, or it's bad for your equipment to get anything wet on the board. Then it's gonna short things out and damage your electrical equipment. Is it okay to work with power supplied to the circuit? Well, sometimes you do that because sometimes you have a circuit on and you want to measure what's going on. So I'm not so sure that question is completely wrong. You got to be very, very careful. Metal jewelry is not a good idea, particularly like a metal chain around your neck and you lean over and that touches something. That's not a good idea. Or even a metal ring is not a good idea because if you touch something electrical, now you've got a big electrical surface, could kind of burn your finger where you have that ring. So the answer is none of the above, but I might quibble with working with when the circuit is powered. Sometimes that's the point. You want to do that. So I kind of quibble with that answer being wrong. Question 3, I'm going to come back to that. That's a tricky question. So what about question 4? When should we apply power to our circuit? So we built some kind of a little circuit here. Should we apply the power first and at the beginning? So while we're building the circuit, the power is on. Or should we apply at any point when building the circuit? Like a half built and then put the power on? Or wait till we got the circuit complete? And this one, I think you can see the answer is we ought to build the whole circuit, check it out real good, make sure we know which hole the wire's going into and which pin on the Arduino, make sure we have it carefully right, and then apply power to it. It's just too easy while you're connecting things to put it in the wrong point while you're working. So you want to get it all done, then check it very well, and then apply the power. That was a pretty straightforward answer. So if an electrical component is damaged, what should you do? Use it, repair it, or replace it? I think they want you to say you better replace it. And all these little components, you can buy these at you don't have like Radio Shacks anymore, but either online you can find all these pretty cheaply, or I buy some of these things at my local Micro Center store. You can buy Arduino kits and lots of little sensors and things that are meant for these kind of computers. All right, let's go back to question 3. This is an important one here. So if you find somebody who is being shocked, maybe somebody's working with a tool in their garage and their hand is, like, remember what I said, when electricity flows through your hand, it can cause you to cramp, cause your muscle to clamp up, and then they can't let go. With high enough voltage, you can't let go. So what should you do? So if they can't remove, I got that a little too big here, if they can't remove themselves from the circuit, what should you do first? Should you tap them on the shoulder and say, hey, are you okay? You okay? Well, that's probably not good to do, because if someone is have electricity flowing through them and you touch them, now it's flowing through you also. So that's not very good. How about this one? How about pulling him or her away from the circuit? Because should you grab the person and pull them away? Well, again, that's got the same problem, because if they have electricity flowing through them and you touch them, you could get shocked also. Well, should you turn off the power to the circuit or go and find help? Now, this is why I came back to this. This is kind of a toss-up to me. Should you just go call 911 and get help that way, or get somebody else to help? The problem is, if somebody's getting shocked, you've got to respond quite quickly. So if you go and find help or call 911, it's going to take quite a while for them to come, and the person could be dead by then, you know. But turning off to the circuit, the power off, isn't something you can always do. For example, what if someone has touched an electrical line that's fall down in the street? Maybe an electrical, a storm, a branch fell on a power line and it fell down in the road and someone touched it. That would be a foolish thing to do, right? But if they're getting shocked, you have no way to turn that off. So that's a situation you have nothing you can do but to go get help, call 911. But if it's something where someone is in their garage and they're getting shocked on a table saw or something, maybe you can find, I guess the answer is, if you know how to turn it off, go turn it off right away. If you don't know, go and find help. Like, for example, if someone's getting shocked in the garage, now typically in the United States, all these outside buildings are supposed to have an emergency disconnect like this. So inside of here, there's this little bar. I don't know if you can tell, well, you can see that in the light here, but if I pull this, like, give that a good hard yank, it disconnects everything. So that's kind of a scary thing to do. But this, if you have a building outside, this would be a way that you could disconnect the power if you have a box looks like that in the back. That's going to be kind of rare. And it's also going to be rare that you have a switch on the wall that controls the outlet where the thing is plugged in, because typically switches on the wall maybe turn lights, but they don't often turn the receptacle on and off. So you might not know. A lot of cases you won't know how to turn off power to the circuit. Another thing, if there's no help around, another thing you can do is, somewhere down in the basement there's going to be a circuit box that has circuit breakers, and if you could flick them off, there's going to be a lot of these, you could turn them all off, or up near the top there's going to be one big switch that turns all the power off to the house at once. I'd use caution with that, because that can be a problem too. When you go into that circuit breaker box, you want to make sure you have good insulated, like, rubber shoes on. I have actually gotten shocked on my circuit breaker box. I had a problem once where there was water running down inside the wire from outside, and all of these little breakers were wet, and when I touched them I would get a little shock off the thing. Very bad. So it was very important there not to have, like, your stocking feet on a cement floor and then touch something that could potentially have electricity. So turning off the power probably is only something you can do if you really know what you're doing. If you know exactly how to turn off the power, yep, go and do that. But if you don't, you're going to have to just go and find help to protect yourself. So I came back to this one because that's kind of a tricky question. So I think that's most of it. Going over this this quiz. Just a few other safety tips. Remember, just never underestimate electricity when you're working with electricity. And even when working with a computer plugged into, Arduino plugged into your computer, it's coming from house current through a receptacle and plugged into the wall somewhere. There's always a potential of danger, and you can't make electricity not dangerous. The only thing you can do is you can make it safe by working safely. So like I said, make sure you don't like touch things with two hands. If you can, work with one hand at a time. So if you do get a shock, it doesn't go through your heart. And remember I said about these, don't touch your fingers on the metal part. Particularly don't touch them both at the same time, because then you could get electricity flowing across your heart. When you're turning the circuit breaker on and off, which something you're not normally going to do unless there's a real emergency, but you really ought to have like rubber Crocs on or something like that to make sure you don't have electricity that could conduct through. Like cement at the floor can be a little damp, and water conducts electricity. So that's, you don't want to have bare feet or damp socks on when you do something like that. So the more you know, the safer you are. So that's why I think it's important, while you're learning about electricity, you're the one that's going to know about it, and you might be in a place sometime in your life where you could help somebody else because you know something. So I'm not trying to tell you what to do with your circuit breakers and things, but the more you know, the safer you will be. I think that's most of the tips I wanted to cover. I say, in general, the voltages you're going to get on here are safe. We're just talking about 5 volts or 9 volts is typically not going to hurt you. Even a 12-volt battery on your car typically is not going to hurt you. Where you're really going to get hurt is if you're getting electricity that's coming from the outlet receptacle in your house. That's the kind of electricity that's going to hurt you, or a power line down in front of the house. You stay away from that. So one of the first things you learn in a first aid course is if someone is in any kind of danger, well, what got them in danger? Is it electrical? Is it whatever else? Whatever the situation was, understand what caused the problem, because you don't want to walk into the same problem yourself. So that's kind of lesson number 1, is to make sure the scene where someone got hurt is safe before you go in and try to touch that person. So there are many times where the best thing you can do is just go in and get help. All right, so that's our lesson on safety. In the next video, we're going to start in on lesson 1 and actually start making some electrical circuits. So now that we've got our Arduino set up, we learned about safety, now we're ready to get in and start actually making some circuits. Cool? Ready to go? We'll see you in the next video.